Hello students, in this video we are going to discuss two topics. First is mass defect and the second one is packing fraction. So first I am starting with mass defect. As we are studying about the nucleus, so we know that nucleus consists of nucleons, that is protons and neutrons. So ideally, if that nucleus is made up of those nucleons, then the mass of nucleus should be equal to the total mass of those nucleons. But practically, when we found this, the condition is not same. So practically it was found that mass of a stable nucleus is always less than the mass of all of its constituent nucleons, that is protons and neutrons. Or we can understand it like this: if we have a nucleus of mass capital M, the mass of this nucleus is capital M, and it has, suppose it has four nucleons or six nucleons in it, right? So this nucleus has, in stable state, it has mass capital M and it has six nucleons. So ideally the situation should be like this: M is equal to mass of 1 plus mass of 2 plus mass of 3 and so on up to mass of 6. But this condition is not valid. What we get practically is the mass capital M is always less than the sum of the masses of individual constituents, right? So this is the condition. So there is a mass difference that we are getting, and this difference of mass is called mass defect. So mass defect can be defined as the difference between the rest mass of a nucleus and the sum of rest masses of its constituent nucleons is called mass defect. Okay, so this difference is called mass defect, and since it is a difference in mass, so we denote it by delta M. By delta M we can denote this mass defect. And if we have a nucleus, let it be the nucleus of some element X with atomic number Z and mass number A, then in that case this nucleus contains Z protons and A minus Z neutrons, right? So its mass is capital M. If capital M is the rest mass of the nucleus, so it should be less than the mass of these, sum of mass of these Z protons and A minus Z neutrons, and their difference is given by delta M. So the value for delta M is Z of mass of proton plus A minus Z of mass of neutron. So this is the total mass of the constituent particles and minus capital M, and this is the mass of the stable nucleus. So there is a difference between these two. Mass of nucleus is less than the mass of sum of masses of constituent particles. So this difference is called mass defect. This is delta M called mass defect. Here MP denotes mass of proton, Mn denotes mass of neutron, and M denotes the rest mass of nucleus ZXA. Okay, these are the terms that we are using to define mass defect. Now the second term that we are going to define is packing fraction. So for the same nucleus, if we find the mass defect per nucleon, okay, mass defect per nucleon, then this ratio is called packing fraction. So packing fraction is defined as the mass defect per nucleon. A is the mass number. A is the mass number which is actually equal to the number of nucleons. A is the sum of number of protons and neutrons or we also call it as number of nucleons or mass number. So that's why if we divide this mass defect by capital A, we get mass defect per nucleon, and that value is given as packing fraction. So packing fraction is defined as mass defect per nucleon. Now if the value of packing fraction is positive, that means this mass defect is positive. If this mass defect is positive, it is showing that this sum is more than the value of capital M. In such case, the nucleus we have is unstable. Nucleus is unstable in case packing fraction is positive. However, if packing fraction is negative, in that case some mass has been converted into energy which is binding the nucleons together, okay, and so the nucleus is stable. This shows that the value of packing fraction is actually directly related to the availability of nuclear energy as well as the stability of the nucleus. So this was the packing fraction and mass defect. We have defined two values, and these two values are used to give the stability of a given nucleus. So that's all for the video. For further videos, stay tuned and keep studying. Thank you.